Hello at home. Here we go. We're on page 31. Let's read this very sneaky problem. There's probably a reason why I'm going through this whole problem with you. Something similar to this might be somewhere next week on Wednesday. Okay. It says, a bag contains N marbles, 2 of which are green. Oh, okay. So out of N marbles, two are green. Oh my gosh. Okay, so we can call this the probability of picking a green marble. What do you think the probability of picking a not green marble would be? Oh, this is very painful. Come on. Do you guys feel my pain? Okay, here we go. Probability of picking a not green marble. Well, let's see. I feel like someone just said it, but they said it under their breath. N minus 2? Right? Because there's going to be N marbles in the bag. 2 are green, so everything that's left over has to be N minus 2. Right? Because if you did N minus 2 for not green plus the 2 that are green, what do you end up with? N, the total number of marbles in the bag. Okay, so it says, Claudia plays a game in which she randomly draws marbles out of the bag, one after another, without replacement. Without replacement means what's going to happen to the denominators as you head down the tree? They're going to go down by 1, because of the one you picked before. The game ends when Claudia draws a green marble. Okay, so let's think about on the first pick what that would look like. She could either get a green marble, in which case the game would end, or she could get a not green marble, in which case the game would continue. What's the probability of picking a green marble on the first pick? 2 over n. Good. And then the probability of picking a not green on the first pick would be n minus 2 over n. Perfect. Now, if the game were to continue, because now we're on the branch where she didn't pick a green, you would do not green, and then green, and I would put a circle around green indicating that the branch terminated, so you don't get confused. Okay, so if you did not pick a green marble on the first pick, how many are left? How many green marbles are left in the bag for the second pick?
2.
Still 2, right? However, what has happened to the denominator? Okay, not greens. I had n minus 2. I had to remove 1 in order to get even on this spot of the branch. So what do I have now for not green? N minus 3. And then what's the denominator? It has to be the same as the one up top, right? So what is it? N minus 1. Good job. Okay. We're going to keep going. All right, I see answer choices that go all the way up to which draw? The 5th draw. So what should your tree model up to? Probably the 5th draw. Now you have everything all listed out, and then you could just start answering the questions, okay? Okay, so this is the 3rd pick. We can see now what's happening to the denominator. It's going down by 1, right? And then let's talk about the numerators, right? If not green, I picked 1. Now what do I have for not green's numerator? N minus 4, right? And then what about the green? He's always seems to be 2, because there's always, you have to get to the terminating branch of picking a green by still having 2 in the bag, right? Okay. Now I'm on my 4th pick. All right. Oh, I forgot to do him green. That's okay. I'll just circle him green. Okay, so now this one is still 2 over, what's the new denominator for this pick now? N minus 3. Good job. So this was first draw, second draw, third draw, fourth draw. Okay. And then now I would have n minus 5 over n minus 3. Yeah? All right, cool. And this is the last one. Yay! fifth draw. Okay, he would terminate here. Fifth draw. That's 2 over n minus 4. And this one is n minus 6 over n minus 4. I'm not going to go any further because they're not asking me about ones that are any further. Okay. Find the probability in terms of n that the game will end on her first draw. First draw, very easy, right? Probability, game ends on first draw. So green on first draw would be 2 over n. It says in terms of n, so I'm not solving anything. I'm done. Second draw. Let's figure out the probability that the game ends on the second draw. Green on second. Draw starts with the letter D, not G. So green on second draw. This doesn't like when I change any color. Why don't you guys try to figure it out while you're waiting for me, and then we'll all come back together. Okay. On the second draw means I go this, this, and I multiply across. So I've got n over 2, or n minus 2 over n. This is getting a little painful, sorry here. N minus 2 over n times 2 over n minus 1. And then we can leave it in terms of n. So I've got 2 times n minus 2 over n times n minus 1. Should you expand or leave it like that? Just leave it. They didn't tell you that you needed to do anything with it, right? So just leave it. Looks good. Okay. And now we can't scroll. There we go. Given that n equals 6. Okay, so now you see that we've given the probabilities all in terms of n up to now. We're going to follow the same structures, except just now we can put a 6 in for n, so that's nice. On the third draw, so the probability that we get a green on the third draw is going to be, I'm not going to highlight because it keeps freezing me. So I'm just going to do not green, so that's going to be n minus 2 over n times n minus 3 over n minus 1 times, and then I'm going to go up to it ending on the third draw. So this is pretty much what I'm doing. 2 over n minus 2. Okay, now before I put that 6 in for n, do you see anything that would make my math easier? Yeah, these guys are going to cancel. I mean, it's not much, but it's something. All right, so I got 2 times n minus 3 over n times n minus 1. 2 times 6 minus 3 over 6 times 6 minus 1. It's going to give me 30 down below and 6 up top, or 1/5. Okay, and that it's still opening stuff, but I'm not even touching it. On the fifth draw, let's set it up the same way, see if anything cancels, and then we'll put in the 6 at the end. Otherwise, we're just doing needless complications, right? Okay. Fifth draw is going to be n minus 2 over n times n minus 3 over n minus 1. I'm just copying from the one above, but then after that I need to go up because I got to see. So it's n minus 4 over n minus 2. So that's 3 picks. Fourth picks n minus 5 over n minus 3. That was the fourth, and then now I can go up to the green pick, which is 2 over n minus 4. All right, so what's going to cancel? I'm not going to change the color. These guys are going to cancel. These guys cancel. Nice. So I have 2 times n minus 5 over n times n minus 1. 2 times 6 minus 5 over 6 times 6 minus 1. It's going to give me 30. 6 minus 5 is 1 times 2, so I get 1/15 or 2 out of 30. All right, I'd like to highlight because I feel like I'm going to be using this stuff. Third draw was 1 out of 5. Fifth draw was 1 out of 15. Second draw was this guy. First draw was this guy. I almost have everything except for which draw am I missing? Oh, interesting. Do you kind of see where this problem could be headed? Maybe, right? Claudia plays the game when n equals 6. She pays $11 to play and can earn money back depending on the number of draws it takes to obtain a green marble. Okay, so it looks like the number of draws it takes to obtain a green marble is located on this top row right here, okay? So maybe you could say, to obtain a green marble. Okay. She earns no money back if she obtains a green marble on her 5th draw. No money back. Go over to where it says green marble on a 5th draw, and you see that that's a 0. Okay, we're like making sense of it. Let M be the amount of money that she earns back playing the game. This information is shown in the following table. Okay, so this row right here, it tells me how much money she earns back for each time the game ends on a certain number of draws. But what it doesn't tell me is the what. In the second row of a probability distribution, we always have the what. The probability that x equals whatever the desired outcome above is for random variable x. So the number of draws is random variable x. We have probabilities for all of those up top. So let's see if we can find the probabilities for the game ending on each corresponding draw. Up top, fill out the table, and then we'll come back in a minute. Okay, so go back and look at your paper and see if you can find the probabilities for the game ending on each draw. We're going to put it in a third row down below. Okay. So this was 2 over n. N is 6, so now we have 2/6 for that guy. Second, you're going to have to plug in the n equals 6 for the second one. So this will be 2 times 6 minus 2 over 6 times 6 minus 1. So then we're going to have 6 minus 2 is 4. 2 is 8. 8 out of 30. Oh gosh. I don't know why this thing is being so slow today. 8 out of 30. 3 was just listed, right? We found it. 6 out of 30. 4 we found. That was 2. No, 4 is the one we did not find, right? 4 is the one we did not find. And then 5th draw is 2 out of 30. It looks like they're all in terms of 30, so I'm going to scale this guy up by multiplying by 5. Do you see why? Then I can really see how many were in that one. All right, so I've got 10 out of 30 for this one, 8 out of 30, 6 out of 30. This one's missing, and then I have 2 out of 30. You could either use the tree to calculate the probability of it ending on the 4th draw, or you could just use the fact that the bottom row of a probability distribution all adds up to 1, and you already have everything over 30, so it should be really easy to figure out, right? So you would do 10 plus 8 is going to be 18, 20, 26. What does this guy have to be? 4 out of 30. Okay? So you're like, yay, I found it. Now we have to find the value of k so that this is a fair game. So if a game is fair, I would write this down probably. If a game is fair, the expected value is either 0 or the buy-in. If there's no buy-in, you want to expect to have 0 at the very end if it's a fair game. That makes sense, right? You're neither winning nor losing anything. Think about it as like your final net. Are you up or down when you leave the casino? Right? Okay. If there is a buy-in, in this case I think there is. Does anyone see a buy-in mentioned? $11, right? So if it costs $11 to play this game, what should she expect to earn back for it to be fair? 11, right? Okay. So do you guys have the formula for expected value memorized, or maybe you want to pull it up on your formula booklet just so you're working with it, right? But essentially all we're trying to do is find out the expected value of x should be equal to 11 for the game to be fair. So now we're going to set up all this other stuff in here, right? So this guy, for an outcome of 1, we would multiply it by this, add it to the next thing, add it to the next thing in order to just calculate the expected value, right? But in this case, each of the outcomes, a 1, a 2, or the game ending on first draw, second draw, third draw, fourth draw, fifth draw, now corresponds to an amount of money earned when that outcome is what happens. So you are now weighting the money earned back with the probability. Does that make sense? Okay. The table helped you set it up so you could see what amount of money goes with which outcome. But now you're going to use your knowledge of expected value to equate the probability with the money earned back. Does that make sense? Because that's the only way it's going to equal $11. You got to have money in there for it to equal $11. Okay. So try to set it up the way that feels natural to you, right? Okay. $11 is what the expected value should equal. $15 will be earned 10 out of 30 times. For that game ending on the first draw. $4K will be earned 8 out of 30 of the times when the game ends on the 2. $10 will be earned back when the game ends on a 3, which happens 6 out of 30 times. $10, oh, I just did that one, sorry. 2K will be earned back when the game ends on the 4th draw, which happens 4 out of 30 times. And $0 is earned back 2 out of the 30 times when the game ends on the 5th draw. Do you see how I set that up? Yeah. Okay, so if a chart is using expected value, using probability distributions, and they just give you the outcome associated with the random variable x, you must make that third row that contains the probabilities. That's what's weighting the outcomes. Okay? All right, so now you just solve this. You could type this into nsolve. Do you guys know how to use nsolve? I mean, you could do it by hand, but it's a lot of fractions and stuff. Why don't we use our tools? Here, check it out. Okay, so nsolve is going to be menu 3, 1. Type it in exactly the way you see it, comma, in this case we're using the variable k, so comma k at the end, okay? So you would have 11 equals plus 0, okay. Close it off, comma, k. It doesn't like the multiply. You have to go back and put in little multiply symbols between the k and the fractions. I was thinking it might not like it, but I said YOLO, and now I'm going back to fix. And now it likes it. So k must be what? K must be 3. So if it went on to ask, how much money would she get back if the game ended on the 4th draw, what would you say? Good job, you got it. Okay, so the answer is k because it asked you to just find the value of k. But now you see how these things kind of work here. All right, the rest of class we're just working through problems. I'm trying to look here and see if there's anything that's really outrageous that you might need help with. Oh, maybe 12. For 12, I would make sure that I illustrate a sample space, right? If E and F are two different die, I would be like, okay, this is for E and then this is for F, right? This is F, this is E. 1, 2, 3, 4, 5, 6. And I would maybe use a different color for the other one so I could really see what's going on here. Oh, there's a red one and a black one. Okay, so maybe if you have a red pen or something. A red one and a black one. And it looks like F and E are referring to events, not necessarily the names of the die. So maybe I would just put this here to kind of remind yourself that that's how you would illustrate the sample space for that to answer the questions. Anything else looks pretty. Pretty okay. 16 is 3 Venn diagrams. We're not doing all of these. You're gonna independently work on Monday as well. I'll finish filling out the board when I'm done going over this. But these are like in the next day. Maybe I'll go over these on Monday then, because they're not in the homework for tonight. But other than that, you should be just fine. Okay, bye.